What we're looking for in this equation is the maximum value that P can have and the corresponding C value, or the C value at which that P value occurs. Well, remember what this curve looked like overall. It was a parabola that opened downward. That means that the maximum point here is just the vertex. So that's exactly what we want to find. This C value and P value that we're looking for are just the coordinates of our vertex. Let's get this in vertex form then. So we just need to go through our typical process of completing the square to get this equation in vertex form. Note that I've actually skipped one step that I included in the past. When I subtract this constant from both sides of the equation, I know that I'm doing that in order to get the right side to equal our perfect square. In the past, I've written out what this entire polynomial is, multiplied out, and then factored it as a step after that, but we don't really need to do that. The reason is that I already know the factored form of the polynomial that we're creating by adding this before I even add on the constant term. The number that I'm adding to C, this negative 46 in this case, is just the coefficient of the C to the first term divided by 2, since that's the thing that we're squaring in order to come up with what we're adding to the end to make this a perfect square. So going through all these steps gives us our final equation of P minus 290,000 equals negative 200 times the quantity C minus 46 squared. From here, we can read straight off that our vertex must be at 46, 290,000. So what does this tell us? Well, it tells us exactly the information that we were looking for. Graham will earn a maximum possible profit of $290,000 per month if he makes his wiper sets cost $46 each.